Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn about observational studies and experiments. All right, so a confounding variable occurs when two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other. Experimental units are the objects to which a treatment is randomly assigned. When the units are human beings, they are often called subjects. Treatment is a specific condition applied to the individuals in an experiment. The control group is a group used to provide a baseline for comparing the effects of other treatments. Depending on the purpose of the experiment, a control group may be given an inactive treatment, an active treatment, or no treatment at all. A placebo is a treatment that has no active ingredient, but is otherwise like the other treatments. The placebo effect describes the fact that some subjects in an experiment will respond favorably to any treatment, even an inactive treatment. Double blind is when neither the subjects nor those interacting with them and measuring the response variable know which treatment a subject is receiving. All right, an example of confounding. In a study of a random sample of 1,739 adults from Nova Scotia, Canada, researchers interviewed each participant and, among other variables, assessed their attitudes using a formal psychological survey. It was found that adults who had a more positive attitude were less likely than their peers to have coronary heart disease over a 10-year period. Based on this study, is it reasonable to conclude that a positive attitude causes a decrease in the risk of coronary heart disease in adults in Nova Scotia? Explain your answer. All right, so no. It is possible that Nova Scotians with more positive attitudes may exercise more often, and that regular exercise decreases the risk of coronary heart disease. So that would be an example of like a confounding variable, something that maybe we didn't measure or link with that. And so now I can't tell, is the result because of their positive attitude or is it because of their healthier lifestyle? Okay. Also, we can't show cause and effect unless we have a well-designed experiment. So we'd have to be assigning treatments in order to show cause and effect. All right, an example identifying treatments. Lobster population in some parts of the world are declining. One solution to this problem is to raise lobsters in hatcheries and then release them into the wild. Growing lobsters as large as possible gives them the best chance of survival when released into the wild. One experiment to determine the best nutrient levels used diets containing two different amounts of protein, 400 or 500 grams per kilogram, each with three different lipid to carbohydrate ratios, low, medium, or high. These diets were compared to the conventional diet of an Antarctic krill that was fed to some of the lobsters. Among other variables, researchers measured the growth rates by the length of the carapace, the upper shell section of the lobster, list the explanatory variables and the number of possible values for each variable. So we have two explanatory variables. We have the amount of protein, and there was two possible values, 400 grams per kilogram and 500 grams per kilogram. And then our other explanatory variable would be lipid to carbohydrate ratio, and there were three possible values, low, medium, and high. How many treatments were included in the experiment? Well, if I do the two types of protein times the three possible lipid to carbohydrate ratios, that would give me 6, plus the original diet, so 7 treatments. So each combo of protein to lipid carbohydrate ratio and the conventional diet. List 2 of the treatments. So there's 7 treatments, we're only going to list 2 of them. So I could do the 400 grams per kilogram protein with the low lipid to carbohydrate ratio. I could do 500 grams per kilogram protein with a high lipid to carbohydrate ratio. Okay, there's several more you could have listed here instead. All right, control. Can reducing calorie intake increase the length of one's life? Researchers randomly assigned 46 rhesus monkeys to a calorie-restricted diet or to a control group that received a standard diet that was monitored to prevent malnutrition. It was found that the CR group lived longer on average. Explain why it is necessary to include the control group. So the control shows how long rhesus monkeys live on average with a standard diet. This group serves as a baseline to determine how much longer monkeys live on average with the calorie-restricted diet. So I need something to compare it to. So I'm just going to keep their regular diet as a control so that I have a baseline to measure against. All right, go Seahawks.